Oumuamua, which is an object that we detected in space that you believe could possibly have been extraterrestrial.
Astronomers were excited to discover the interstellar object last year. It was named Oumuamua. That's Hawaiian for messenger or scout.
In the vast expanse of our universe, there are puzzling entities that captivate our imagination, challenging our understanding of the cosmos. One such interstellar visitor, Oumuamua,
at which point I started thinking maybe it's not a comet and not an asteroid, something else.
has sparked intense debate among scientists and astronomers since its discovery. But now, a chilling warning has been issued by a prominent scientist. Oumuamua is on a collision course with Earth. What is Oumuamua? And why does its imminent collision carry such profound implications for humanity? Join us as we plunge into the chilling alert. Oumuamua's will crash in 2 weeks. Oumuamua, a cosmic mystery. When the Pan-STARRS 1 telescope in Hawaii spotted a never-before-seen asteroid on October 19, 2017, it sparked immense excitement. As astronomers examined it closely, they realized this object was unlike anything they had encountered. The scientific community was excited, sensing they had stumbled upon something extraordinary. This newfound celestial body marked a groundbreaking moment. It wasn't just an asteroid, but the first known interstellar visitor. Its arrival heralded a new era in space exploration, challenging conventional wisdom and igniting a fervor of curiosity. Named Oumuamua, meaning messenger from far away in Hawaiian, this mysterious object captivated researchers. Its discovery shattered established astronomical norms, presenting a unique opportunity to delve deeper into the mysteries of interstellar space. With Oumuamua, the universe unveiled a whole new realm of possibilities, beckoning scientists to explore the unknown with renewed vigor and wonder. The discovery of Oumuamua didn't just cause a stir in Hawaii. It sparked a worldwide effort to study it using telescopes. Astronomers from the Stockholm Environmental Institute eagerly joined in, hoping to glimpse this intriguing object and even search for signs of extraterrestrial life. Oumuamua puzzled scientists with its strange shape. Instead of being round like most asteroids and comets, it was long and skinny, resembling a cigar or even a needle. This unusual shape sparked a lot of questions about where Oumuamua came from and whether it posed any danger to us. Some scientists think its shape might be the result of its long journey through interstellar space, where it might have collided with other objects or been worn down over time. Speaking of speed, Oumuamua zoomed through our solar system at an astonishing 35,000 kilometers per hour. That's much faster than any asteroid we know of, which usually only speed up when they get close to the sun. Oumuamua's speed and trajectory were also affected by the sun's gravity when it swung by. So, Oumuamua's weird shape and incredible speed made scientists scratch their heads and watch closely as it zipped through our solar system, leaving them eager to uncover more of its secrets. When Oumuamua approached the sun, it didn't behave like other objects we know. Typically, when asteroids or comets get close to the sun, they follow a predictable path due to gravity. Scientists have studied many of these objects, observing their orbits closely. But Oumuamua was different. As it neared the sun, Oumuamua veered off course in an unexpected way. This wasn't something gravity alone could explain. Something else seemed to be at play. One possible explanation could be the release of gases, which is common for comets. When these icy bodies heat up near the sun, the ice turns into gas, creating a sort of propulsion. But here's the mystery. No one saw any gases coming from Oumuamua. So, where did this extra push come from? It's a puzzling question that continues to baffle scientists. Through theories and speculations, many theories floated around to explain what Oumuamua really is. The way this object sped up got many folks thinking it might be an alien spaceship, maybe some kind of probe powered by an internal energy source. What's even stranger is, nobody knew which solar system it came from or how old it was. It was zooming so fast that telescopes couldn't snap a clear picture to show us what it really looked like or what it was made of, adding even more mystery to the mix. Some researchers have come up with pretty wild ideas about what this first interstellar visitor could be and where it might have come from. Abraham Avi Loeb, an Israeli-American theoretical physicist, even suggested that Oumuamua is an alien spaceship powered by a light sail, a method that uses the sun's radiation pressure or huge mirrors to push a spacecraft forward. The only way to explain Oumuamua's strange speed boost without assuming some kind of unseen gas release is to think it's propelled by solar radiation, like photons bouncing off its surface. But for that to work, the object would have to be super thin, no thicker than a millimeter, with a really low density but a big surface area. This concept, called a light sail, has been tested in space missions like Japan's probe and NASA's NanoSail D2. These sails use the energy from photons to push themselves forward. Now, imagine if this object were not propelled by wind, but by the gentle push of light itself. Such a creation might naturally occur in the cosmos, but it leaves us with a puzzling question. Could Oumuamua have been intentionally crafted and sent out by intelligent beings from beyond our world? This notion gains weight when we consider the absence of a comet tail, typically seen when objects release gases as they journey through space. Without this telltale sign, the possibility of Oumuamua being of artificial origin becomes even more intriguing. The idea that Oumuamua could be a product of extraterrestrial engineering is both fascinating and perplexing. While it's a bold claim, coming from a reputable scientist, it's still one that's hard to prove or disprove. However, another theory has emerged that offers a different perspective. Some now speculate that Oumuamua might resemble a flat, disc-like shape, similar to a pancake or a large, cookie-shaped piece of debris. This notion suggests it could be a fragment ejected from an exoplanet, similar to Pluto, during a cataclysmic event. In 2021, two researchers from Arizona State University released a pair of papers proposing an intriguing idea that Oumuamua could be a hydrogen iceberg. They believe that a celestial body struck the planet where Oumuamua originated, causing a violent collision. This collision flung a chunk of the planet into our solar system around 400 to 500 million years ago. However, for this theory to hold true, Oumuamua would have to be smaller than initially estimated. When Oumuamua was first discovered, scientists thought it might be a long, thin object resembling a cigar, tumbling through space. But there was something odd about its movement. It seemed to be speeding up, as if being pushed by an unseen force. This mystery only deepens the intrigue surrounding Oumuamua's origins and journey through the cosmos. Initially, astronomers were thrilled to find that Oumuamua seemed to be heading towards Vega, the brightest star in the Lyra constellation. This star was known to have a debris disk. Calculations hinted that Oumuamua could have traveled to its current position in about 600,000 years. However, later observations challenged this idea as Oumuamua's path showed significant deviations. Instead, astronomers speculated that Oumuamua might have encountered a new star system for the first time, judging by its motion around the Sun, which matched the speed of nearby stars. However, there's also a chance that Oumuamua has been journeying through the galaxy for billions of years. Tracking Oumuamua's journey. The latest update on Oumuamua is quite the twist. From cruising out of our solar system, it's now predicted to be on a crash course. But where? Could it be headed straight for Earth? Before we delve into that nail-biting scenario, let's rewind a bit and understand Oumuamua's journey so far. Scientists have been carefully tracking Oumuamua's path, trying to predict its next move. Despite taking billions of years to reach our cosmic doorstep, Oumuamua's presence is just a blip in the vastness of the Milky Way galaxy, which has been around for a whopping 10 billion years. During its journey, Oumuamua likely passed through around 20,000 star systems, a mere fraction of the galaxy's 200 billion stars. But even so, it would have stirred up dust and debris, creating opportunities for cosmic mingling among the stars. Now, about that crash landing. Astronomers had predicted Oumuamua might swing through the Kuiper Belt this year, but so far it remains elusive. They're working with the information they have to track its movements and anticipate its potential arrival on Earth. But here's where things get really interesting. Oumuamua's trajectory isn't following the usual rules. Instead of just being pulled along by gravity, it's experiencing some unexpected acceleration. Scientists have proposed several possible explanations for this, with the most common being outgassing. This phenomenon occurs when a comet gets close to the Sun, causing its surface ice to turn directly into gas, propelling the comet forward. This process, similar to what happens with comets, gives the comet an extra boost, changing both its speed and how it spins. Scientists used the Spitzer Space Telescope to observe Oumuamua for over 30 hours, hoping to detect its thermal properties. However, they faced challenges in their attempts. It was noted that although they detected heat emissions using a thermal infrared test, they didn't find any significant results. However, they speculated that if Oumuamua behaves thermally like a comet, it might be brighter than expected. An object's reflectivity, or how much light it bounces back, can reveal a lot about its size, makeup, and shape. Despite all the theories and ideas, the true identity of this interstellar object remains a mystery. So, while Oumuamua's path may be unconventional, it's also teaching us a lot about the mysteries of our cosmic neighborhood. Unraveling Oumuamua's puzzle. Two American astronomers believe they've cracked one of the lingering mysteries surrounding Oumuamua. When it first visited our solar system, scientists quickly realized it was on what's called a hyperbolic orbit, a fancy term for a boomerang-shaped path. This indicated that Oumuamua wasn't from around here, it was just passing through and wouldn't stick around. But is that really the end of the story? Will Oumuamua truly vanish forever? One fascinating thing about Oumuamua is its speed, which seemed to pick up as it zoomed past the sun. Normally, big objects like planets and stars can give smaller ones, like comets and asteroids, a gravitational push that speeds them up. But Oumuamua was different. It was cruising at an incredible speed, 3 times faster than an average comet in our solar system. Even with gravitational kicks taken into account, this super-speedy acceleration was puzzling scientists. This mystery led many to lean towards Oumuamua being a comet rather than an asteroid. But it's one of those puzzles that's been giving scientists a real run for their money. Comets in our solar system get a boost in speed when water and dust evaporate from their icy cores as they approach the sun. These comets are known for their stunning tails that shine brightly because of this evaporation process. However, Oumuamua, unlike typical comets, didn't have a tail. Many scientists have puzzled over how Oumuamua sped up without a visible tail. Previous explanations fell short, leaving gaps in our understanding. Now, in a fresh study, Jennifer Bergner, a chemistry assistant professor at the University of California, Berkeley, and Daryl Seligman, a postdoctoral fellow at Cornell University, supported by the U.S. National Science Foundation, introduce a new theory that promises to shed light on this mystery once and for all. For years, Seligman has been on a quest to understand outgassing, a mysterious process in space. Initially, she suspected that the amount of dust being emitted wasn't sufficient to explain it. Later, she considered the possibility that the material causing outgassing might be more volatile than what's typically found in comets, like hydrogen, nitrogen, and carbon monoxide. But these explanations faced challenges. For instance, freezing hydrogen into objects as large as Oumuamua would require temperatures colder than those found in the dense clouds where such objects originate. Additionally, there isn't enough nitrogen spread throughout the Milky Way to justify the expected number of similar bodies in the galaxy. Now, Seligman and Bergner suggest a different perspective. Perhaps Oumuamua's chemistry isn't as extraordinary as previously thought. Instead, they propose that the object underwent unique processes beyond our solar system, processes that we haven't yet witnessed with our observations of domestic comets. Bergner adds an intriguing idea. As a comet travels through the vastness of interstellar space, it gets bombarded by cosmic radiation, essentially cooking it and creating hydrogen in the process. They ponder, what if this hydrogen gets trapped inside the comet, only to be released when it warms up upon entering our solar system? It's a captivating theory that adds layers to the mystery surrounding this enigmatic visitor from the depths of space. The team's calculations revealed something fascinating. They found that the force from hydrogen outgassing could potentially explain why Oumuamua behaves so strangely. They delved into experiments, showing how energetic particles, like the ones found in cosmic rays, could split hydrogen molecules from water ice, but still keep them trapped inside an icy shell. Seligman was particularly impressed with Jenny's idea. He remarked, "It's elegant, because it fits perfectly with what we know about interstellar comets." We entertained all sorts of wild theories, like hydrogen icebergs, but this explanation seems to be the most plausible. However, not everyone is convinced. Avi Loeb argued that Seligman and Bergner overlooked the true surface temperature of Oumuamua, leading to an incorrect estimate of the amount of hydrogen available in the iceberg. Avi Loeb, who once speculated that Oumuamua might be an alien spacecraft, believes that the outgassing of hydrogen couldn't have caused the observed acceleration. With Oumuamua now vanished into the depths of space, its secrets may forever remain hidden. Seligman holds out hope that new interstellar visitors will grace our skies soon, offering astronomers another chance to unlock the mysteries of distant star systems within our Milky Way galaxy. Excitingly, new telescopes on the horizon promise to revolutionize this field of study within the next decade. Beyond Oumuamua, 2I Borisov. The Hubble Space Telescope captured images of 2I Borisov, the second spotted interstellar visitor after Oumuamua. This celestial wanderer was spotted by Gennady Borisov, an amateur astronomer and telescope craftsman from Crimea, on August 29, 2019. These pictures were crucial for scientists to determine what Borisov was and how it differed from Oumuamua. Like Oumuamua, Borisov is remarkable because it comes from outside our solar system. However, scientists are not just intrigued by its origin, but also by what it can teach us about the universe beyond. Even though other star systems may be different from ours, the fact that this comet's characteristics resemble those of the materials that formed our solar system is quite remarkable, commented Amaya Moro-Martin from the Space Telescope Science Institute. What makes it even more captivating is its rapid movement. Racing through space at an astounding speed of 110,000 miles per hour, Borisov follows a hyperbolic path around the Sun, which means it won't linger for long. Unlike most objects in our solar system, it won't be affected by the Sun's gravitational pull. Based on its velocity, scientists anticipated that Borisov would zoom past Jupiter and then disappear into the vastness of space, never to return. As Oumuamua continues its journey through our solar system, NASA and other space agencies are in a race against time to uncover more about its composition and behavior before it bids farewell. Max Muchler, another member of the observing team, highlighted the unpredictability of new comets, emphasizing that they may suddenly brighten or break apart when exposed to the sun's intense heat for the first time. With its advanced sensitivity and resolution, the Hubble Space Telescope stands ready to monitor whatever unfolds next. Despite the time constraints, space teams worldwide are working tirelessly to secure more observation time, eager to uncover additional details about Borisov before its fleeting visit concludes. While scientists anticipate gathering more information about Borisov in the coming months or years, we already have some clues about its nature. It has been identified as a comet, a significant detail that helps characterize this interstellar traveler. One key indicator of its cometary nature is its coma, the hazy cloud surrounding the comet as it journeys through space. The fuzziness surrounding Borisov arises when its rocky core interacts with the intense heat from a nearby star. This interaction causes parts of the comet to melt partially, releasing gas and dust into space. Estimating the size of the comet has proven to be quite challenging. As it travels through the vastness of space, different observing technologies have provided fluctuating estimates of its dimensions. However, current assessments suggest that the nucleus of the comet ranges from approximately 1.4 to 6 kilometers in diameter, making it quite large. In many ways, Borisov behaves like a typical comet found in the universe, albeit with a unique twist. It's hurtling through various star systems and happened to come close to our own. On the other hand, Oumuamua captivated astronomers with its unconventional features. Unlike most comets, it lacked the expected tail and coma, leaving experts scratching their heads in confusion. Despite earlier predictions about the existence of interstellar objects, Oumuamua's peculiar appearance caught everyone off guard. Some speculated that its unusual characteristics might be attributed to outgassing, possibly from the sublimation of hydrogen or nitrogen ice, originating from another solar system. Now it's time for today's subscriber pick. As the crimson hues of twilight enveloped the observatory, Dr. Aidan Locke's frantic footsteps echoed through the halls. His fingers trembled as he typed the ominous warning onto the computer screen. Scientist warns, Oumuamua will crash in 2 weeks. The world held its breath as the news spread like wildfire. Amidst the chaos, a young astronomer named Maya stood transfixed by the sight of the distant celestial visitor through her telescope. Oumuamua, the strange interstellar object, danced gracefully through the cosmos, oblivious to the impending catastrophe. With each passing day, tension mounted as the scientific community raced against time to decipher the mysteries of Oumuamua and find a solution to avert disaster. Governments mobilized resources, and people around the globe united in hope and fear. In a daring mission, Maya and a team of fearless astronauts embarked on a journey to intercept Oumuamua. Their mission: to alter its trajectory and save Earth from devastation. As they neared the fateful day, Maya gazed out into the endless expanse of space, her heart heavy with uncertainty. Would their efforts be enough to alter the course of fate? In the end, the title proved prophetic, but humanity's resilience prevailed as Oumuamua's collision was diverted, sparing Earth from destruction. And in the quiet aftermath, amidst the stars' whispered secrets, Maya realized that some destinies are ours to shape. What do you think about Oumuamua? The frontiers of astronomical discovery. About 6 months before Oumuamua's close call with Earth, a tiny interstellar meteor called M2 made a splash on our planet. Although unrelated to Oumuamua, this meteor caught the attention of Avi Loeb. He pondered the idea of an artificial object acting as a parent craft, deploying smaller probes as it passed by Earth, similar to NASA's spacecraft missions. In a draft study, Professor Donald Kirkpatrick and Avi Loeb delved into mysterious phenomena termed unidentified anomalous phenomena by the government, all while sticking to accepted laws of physics. They speculated that the craft's propulsion, or the gravitational pull from the sun, could release these probes, likened to dandelion seeds separating from their parent plant. These scientists theorized that because of their small size, the probes might go unnoticed by survey telescopes as they journeyed toward Earth. They envisioned these probes equipped with technology to regulate their descent through Earth's atmosphere, avoiding burning up and landing softly, much like parachutists. The probes, they suggested, might be interested in studying rocky planets with atmospheres in our solar system, such as Mars, Venus, and Earth. Furthermore, the extraterrestrial society behind these probes might not need to remain on the mothership once they find evidence of liquid water, according to scientific theories. It's highly unlikely that the mothership could communicate with these probes. But here's a fascinating thought. Imagine a planet capable of hosting intelligent life sending out probes long before Earth even thought of doing so. Avi Loeb compares it to checking your mailbox from time to time, even if the senders are long gone, just in case some surprise packages are waiting. Since Avi Loeb first suggested that Oumuamua might be an alien spacecraft, he's faced pushback from the scientific community. Some find his idea that Oumuamua was deliberately sent to Earth both provocative and unsupported. In 2021, a letter was published in the journal Astronomy and Astrophysics denying the possibility of interstellar travel. The authors pointed out the immense time needed to travel between stars, leading them to believe that it's more likely that Oumuamua is just an oddly shaped rock that wandered into our solar system rather than a deliberate creation of an alien civilization. Another analysis has effectively disproven the idea that Oumuamua moved like an alien spacecraft. Instead, it suggests a possible explanation: hydrogen off-gassing, which occurred on March 22, 2023, seems to be the most likely cause for its peculiar behavior. Meanwhile, the Pentagon has recently intensified its efforts to investigate unusual aerial events in U.S. airspace. The All-Domain Anomaly Resolution Office, since its inception, has launched over 360 new inquiries into reported encounters with unexplained aerial phenomena by U.S. military personnel. About half of these incidents have been attributed to balloons or similar objects, while the other half lacks sufficient data to draw definitive conclusions. In the pursuit of knowledge, visionaries like Elon Musk believe that advanced telescopic scanning could unveil more alien objects. These discoveries could provide valuable opportunities for researchers to test their theories. The parallels with the discovery of exoplanets offer a promising example of such endeavors. Just 2 decades ago, we found the first exoplanets beyond our solar system, and since then, our understanding has expanded significantly, confirming the existence of over 4,500 exoplanets. This path underscores the rapid progress in the realm of astronomical exploration. As scientists pondered the potential of reaching Oumuamua and its potential arrival on Earth, discussions flourished among the scientific community. Oumuamua's potential return. Contemplating the potential return of Oumuamua prompts us to consider our next moves. Constructing a spacecraft capable of chasing it requires a deeper grasp of dark energy's mysteries in the cosmos. One proposal is to send a craft in pursuit of the asteroid probe, but the task is monumental. Oumuamua hurtles through space at a staggering hyperbolic excess velocity of 5.5 astronomical units per year, zooming past Saturn's orbit in just 2 years. This velocity surpasses anything humanity has ever sent into space. So, what kind of vessel would suffice? And what propulsion method should we employ? Solar sails or perhaps something more exotic like a wormhole? Yet, the idea of wormholes presents formidable challenges, including potential collapse, connections to other universes, and the lack of construction knowledge. Cosmic gateways and interstellar travel trace back to 1935, when Albert Einstein and Nathan Rosen introduced the captivating concept of wormholes within the framework of general relativity. They envisioned Einstein-Rosen bridges, or wormholes, theoretical passages linking different points in space-time. These wormholes could potentially create shortcuts, slashing travel distance and time across the universe. Despite Einstein's equations suggesting their possibility, no wormholes have been observed or confirmed to date. Some equations even hint at wormholes associated with black holes, but confirming this remains challenging. Objects and beings entering black holes face uncertain destinies, making it impossible to verify if they connect to wormholes. At the core of this concept lies Einstein's theory of space-time, portraying it as a fabric enveloping the entire universe. According to Einstein, the interaction of mass and energy warps this fabric, creating valleys that shape the movement of celestial bodies such as planets and stars. The bending and shaping of space-time lay the groundwork for gravitational effects rather than a straightforward pull of gravity. Einstein had a hunch that space-time could be manipulated even further, perhaps torn apart, which led to the concept of wormholes. This intriguing idea proposes that if a hole were to be opened in space-time, there must be something waiting on the other side. What's fascinating is that Einstein and other scientists have proposed the existence of different types of wormholes, each with its unique characteristics. Among them, traversable wormholes steal the spotlight. Often featured in science fiction, these serve as cosmic shortcuts between distant points in the universe, like the wormhole in Star Trek Deep Space Nine. On the flip side, non-reversible wormholes pose more challenges. They may collapse before anything can traverse them, or they might lack an exit point, effectively trapping anything that ventures inside. Consider the idea of one-way wormholes. Picture a tunnel in space where you can go in from one end, but can't return unless you find another tunnel. Now here's where it gets intriguing. Einstein's equations hint that these wormholes might hide within black holes, although they're currently impassable. On the other hand, we have white holes, the opposites of black holes, spewing out matter with immense force. Then there are two-way wormholes, offering a two-way ticket for space travel, making round-trip journeys possible. Intra-universe wormholes lurk within our universe, acting as cosmic shortcuts between different points. Inter-universe wormholes take it a step further, linking our universe with another parallel one, opening doors to vast possibilities beyond our imagination. So, where do we find these wormholes in the vast expanse of our universe? Theories suggest they could lurk within the depths of black holes, white holes, and other colossal celestial bodies. But as of now, they remain largely hypothetical, shrouded in mystery. This uncertainty is typical in the field of science. Just because something is theoretically possible doesn't guarantee its existence. It's just like dark matter and dark energy, ideas supported by mathematical models yet awaiting concrete proof. Einstein's theory of general relativity offers a sturdy mathematical scaffold for the existence of wormholes. But remember, theories, no matter how robust, are still open to interpretation and further investigation. So, while we may fantasize and ponder about these cosmic shortcuts, their elusive nature serves as a reminder that there's still much to uncover about the boundless cosmos. Perhaps one day, under the right circumstances, we'll unlock the mystery of these cosmic shortcuts. However, according to Einstein's theory, wormholes are similar to fractures in the fabric of space-time. But it's conceivable that nothing in the vast expanse of the universe has managed to pierce through this fabric yet. It's not that it's impossible, it simply hasn't occurred. Now, let's entertain a thought. What if we're meant to create our own wormholes? In some science fiction narratives, spacecraft tear through space-time, forging their shortcuts. Could it be that natural wormholes elude us because we're meant to craft them ourselves? Alternatively, these cosmic shortcuts might already exist out there, waiting for us to stumble upon them. But how could we overlook a wormhole in space, you might ponder? Consider the sheer magnitude of the cosmos, spanning trillions of light years. Despite our diligent efforts to explore it, we can only observe a tiny fraction with any regularity. We marvel at stars and planets in distant galaxies, yet continue to uncover new moons within our solar system. With our limited ability to survey the cosmos, it's no wonder that some phenomena evade our detection. Do you think that Oumuamua will return and crash into Earth? Let us know your opinion in the comments below.